Hi guys, welcome back to the channel. This is Achyut. So we are going to be solving today's lead code question, which is linked list cycle. So we are given a head of the linked list, and then we need to find whether the linked list has a cycle or not. Suppose let's take this particular example. Here we have the nodes like 3, 2, 0, and then -4. At the tail of the linked list is connected to one of the node which is present in the linked list. So it has a cycle. So we need to return it as true. Suppose if we take this particular case, here also it has a cycle. So we need to return true. And then for this linked list, it is a linear linked list. So we do not need to return it as a true. So for this particular case, if we observe this, suppose let's think the linked list is linear. That means it doesn't has any cycle. That means suppose let's say we take here, we take the current node as here and then move from here to here. Like we'll move from here to here and then from here to here and then again move to here and here and then from here to here and then again here to here. And then after completion of traversing all the nodes, we'll go to null. That means there will not be any nodes which are present like this. And then let's think we have we have one more cycle. Let's say we have a cycle. For this particular case, after coming here, we'll go to this node and then again to this node and then again to this node. And then after coming here, when we traverse from here to here, again it repeats a cycle. That means whenever we are in a cycle, we'll keep on moving when we move the current node to next node. Suppose let's think we need to find whether this is the linked list has a cycle or not. Suppose if it doesn't has a cycle, then we'll end up having null value, which is like this. It will move to here, like having the null value. Suppose let's say we have this cycle. That means whatever the node which is previously visited will be visited again. That means we can track the nodes which are already previously visited. That means we can keep a map so that it will store whether this particular node is visited or not. Then after coming to here, we can say that this particular node is already visited. So we are visiting again. That means it is a cycle. So we'll return true. For this particular case, if we see the time complexity, it is going to be big of n. But if we take the space complexity, we are going to maintain all the nodes which are visited. So it is going to be big of n. The space will be. So let's optimize this via better solution by taking one of the case. Like we can take slow pointer and then fast pointer. It is going to be intuitive. So let's focus on that. So let's assume that this is a linear linked list and then we need to return false for this. So let us assume we'll start slow and then fast pointer from here and then we'll move the fast pointer to 2 steps and then for slow pointer we'll move to 1 step. So at the first step it is going to be slow pointer is going to be at here and then fast pointer is going to be here. And then for the next step the slow pointer is going to be here and then fast pointer is going to be here. And then in the next step it is the fast pointer is going to become null and then slow pointer will come to this particular node. So whenever the fast pointer gets null or the fast pointer next becomes null, then we can say that this particular linked list doesn't has a cycle. So whenever we have that particular case, we'll return that this particular linked list doesn't has any cycle. So let us assume that we have a cycle. We have a cycle like this. For this particular case, to check whether it has a cycle, we'll use slow and fast pointer. So let us think a bit differently. Suppose let's say we have a linked list and then we have slow pointer here and then fast pointer here. For this particular case, we need to find whether the fast can meet slow pointer or not. For the first step, it is going to come here, and then for the fast pointer it is going to come here, and then for the slow pointer the next move will be like this, and then the fast pointer next will be like this. So the fast pointer and slow pointer will meet when the difference between when the number of nodes in between them is only one. Suppose let's think if we have only two nodes which are present in this particular case. Suppose let's take slow pointer where it has two nodes in between uh, two nodes in between the fast pointer and then slow pointer. So for this particular case we are going to say this is a fast pointer and then this is a slow pointer. Suppose if yeah, this is a slow pointer because the number of nodes is like we are taking it as 2, previously we took it as 1. So if we move the slow pointer to here and then fast pointer to here, here the distance between the slow pointer and then fast pointer became 1. Previously it was 2, now it is 1. And then if we move slow pointer to here and then fast pointer to here, the distance is like only 1. And then if we have one more node and then slow pointer becomes here and then fast pointer will be here. So whenever the distance between the fast pointer and then slow pointer has some distance, whenever the fast pointer makes a move, the distance between them becomes like one distance lesser. So whenever we say the fast pointer is behind the slow pointer and then slow pointer moves one step ahead, one node, and then fast pointer moves two nodes, then we can say that fast pointer will catch up the slow pointer at some particular point when it moves in same direction, and it is not like a circle. So let us think in terms of cycle. So let us assume that we have a cycle. We have this particular cycle where we have node and then we have like this. So let us assume that the fast pointer will be here and then slow pointer will be here with some distance. Okay. And then we need to check whether if the slow pointer moves two steps forward and then slow pointer moves one step forward, whether this is it possible to is the fast fast pointer is able to meet the slow pointer. So let us think the fast pointer will move like this and then slow pointer will move like this. For this particular fast pointer to catch up the slow pointer, the distance is going to be 1 and then 2 and then this is 3. So the number of nodes in between them is 2 and then the distance between them is 1, 2 and then 3. So for this particular case, if we move slow pointer to here, the fast pointer will move to here and then this will not be there and then this will not be there. And then again we need to move the slow pointer and then fast pointer. Previously the distance between them is 1, 2, 1 and then 2 and then 3. Now the distance between them is 2. Why? Because it has two edges. So the distance between them is 2. And then we again will move the slow pointer. Slow pointer will come here and then fast pointer will be here. And then for this particular case, the distance between them is only 1. So the distance has got decreased. Now again we'll move the fast pointer and then slow pointer. The slow pointer will get here and then the fast pointer will also get here. So whenever they were in the same cycle, they will definitely meet. Why? Because as we have already seen for the list where the fast pointer is always behind the slow pointer, it will always meet at some particular point by decreasing the distance one at uh, one distance via each iteration that fast pointer and then slow pointer makes. Why? Because the fast pointer moves 2 steps and then slow pointer moves 1 step, so the distance between them got decreased via one distance. So that is going to be the intuition for this. And then let's focus on what is the code we should write. So we'll take the slow pointer as head and then fast pointer as head, and then we'll check whether the fast pointer exists or fast next exists. If one of them becomes null, then we can say that this is a linear linked list. It is not a cyclic linked list. So we can return it as false, and then we'll move the slow pointer to the next step, and then fast pointer to the next, and then we'll check whether this slow meets the fast. If it meets the fast, that means we have a cycle. So we are going to return it as true, and then we are going to, if uh, after moving each step, we are going to do the same again and again till the slow becomes fast or the fast becomes null. So this is going to be the intuition. And then if we come to the time and space complexity, the time complexity is going to be big O of n, and then the space complexity is going to be big O of 1. Yeah, that's all for this video. Thanks for watching the video. Have a nice day.